Hi there, my name is Ian McTavish. I'm the programming mentor for Team 4152, and this is our tutorial on creating our robot for FRC. This tutorial is geared to our own team in terms of getting set up with our program for the year, but if other teams find it useful, that's great. Our team is very thankful for the sponsorship of all these companies and individuals that allow our team to be successful. Now, before we begin, WPI library, this is where all the documentation is, and there's basically kind of step-by-step directions posted each year on how to create a basic robot program, how to wire up your program. And it's really important to read through this so that you understand it. And even if you've read through it one year, the next year, read it again, because there will always be new things that are added that we want to make sure we're on top of. And it's also just a good refresher to go, oh yes, I didn't remember that was possible. When you do the installation, you want to make sure all your software and libraries are up to date. And for the 2021 year, we are using VS Code, and we're programming in Java. And each year we tend to stick with Java. We have programmed in C++ before, and we tend to use whatever IDE, in this case it's VS Code, is used. Now, before we can program our robot, we need to have an actual robot to program. And so we do have a practice space. And with the practice space, we are using Talon motors for the left and right side, Talon motor controllers. And the key reason for this is that we no longer use these ones in competition. So we've got them handy, and we want to get a programming base set up really quickly so that you can do some practicing, and then we can fine tune it and change to the motor controllers that we're using on our competition robot. So those will be covered in a later tutorial. So with the Robo Rio, you want to make sure that the wiring is set up. And for this, we're going to be using PWM. In competition, we use CAN bus, but we will be covering that in a later tutorial. PWM typically takes 3 wires. So you have your white signal wire, your red power wire for 5 volts, and your ground wire, which is black. And if you look on the bottom of the Robo Rio, you can see there's little icons, signal, volt, ground. That helps you orientate yourself to where everything goes. So it's always important to look at these different icons so that you understand them. And you can see the Talon motor controller also takes power in, positive and negative, and outputs power to the motor. You can see there's a little M here indicating this side is the motor. And you want to make sure that everything is wired up. You have your fuses set up properly, and you've had somebody double check everything. So the left motor is going to be plugged into PWM 0. The right motor is going to be plugged into PWM 1. So let's get started, and I'm going to switch over to VS Code. So in VS Code, when you've got it set up, and you can set it up on your home computer, we also have some robotics laptops that we use for this. Control-Shift-P is the key command, and the slideshow with all these commands, there's a link for that as well. Control-Shift-P is the command, and when you're in here, you can just start typing WPI LUB, the LIB, and you can see create a new project. So that's what we're going to select. And it's going to come up with all of this information. So we want to make sure that we go through this. So the first thing is select a project type. We are going to use a template for this. Select a language, Java, and then a program base. And for this, we are using the command robot. Now, selecting a folder, we can pick basically on our programming laptop, we have folders for each of these, and so you can do that. I'm just going to call this a tutorial. Typically, we'll have Team 4152 and the year. and no spaces in our names at all. So there's my project folder. Enter a project name. I'm going to call this 2021 tutorial, and our team number is 4152. So those are the things that we can do. We can check this off, make sure you read it, and you always look at where you can set things if you want to make a change. So we're going to generate the project, and this is going to open up, and we're going to use this in the current window. And so we have a whole bunch of files over here. So with the tutorial, you'll notice there's different folders. We want to go to our source code and our Java code, and in here we've got all of our files. Now, there's a lot of things to set up. The first thing is we're going to set up our constants. And so with our constants, these are settings that we're going to use in multiple locations within our program. So we want to make sure that we have access to them. So the first one is we're going to set up our drive controls. And you'll notice what I've done is on line 18, public final class constants. So constants is the class for this, and you'll notice that's in a file called constants.java. So I'm looking for that. There's squiggly braces, and so I am going to be putting my code in between these squiggly braces. First thing is the 2 slashes. This indicates that this is a comment, and we comment our codes so that we understand where things are and we can access them. Now, we're going to create a public static final. And what this is public means that all of our other classes can access this. It's public. Static means that we don't need to create an instance of the constants class. We can just access this, this variable. And final indicates that once we set it, we are never going to change it. And that is really important. Obviously, we could change it and recompile the code, but that way we don't have code that will accidentally change the value and have weird things happening. So we're going to add hand and drive. Whoops, I'm going to capitalize this. So hand is going to be, there's a problem with this, so we're just going to figure out the problem. So it can't be resolved to a type of Java. So that's where we're missing an import. So we'll need to import the right class. But we're going to do that in a moment. You'll notice as I type, we got IntelliSense. So hand right here, you can see is part of the WPI library. So we are going to select that one, and K left is going to be what we're going to select. Now, you'll notice it automatically added the import. So everything in the WPI library is what we need to use to be able to access the different elements of our robot. So what this is K left. This indicates that the joystick on the left is going to be what we are going to associate with driving the robot. So that's the purpose of that. We can structure different variables so that we can set our buttons. And so we try to do this in our constants because then we can access it later on. And if we change drivers and the driver goes, oh, I need to change the pressing this button doesn't work. I want to press this button. We can change it in one spot and it will change for everything because everything's referring to that. So that's the easy part for that. And that is our hand drive. And what I'm going to do, I'm actually going to put this into its own class. And you can see I've added squiggly braces. So with the squiggly braces, there, Now, we like putting this in our own class just so everything's structured and it's easy for us to access. Now, the next thing is USB IDs. So our USB IDs, this is, we can determine which joystick we plug in and to access. So again, public static final. This time we're dealing with an integer. And the integer is going to be set to a value of 0. So int is the integer data type. It's a primitive Java data type, which is different from something like hand, which is part of this particular class. Driver's the name of it, 0. So this means that when we plug in two joysticks, the first one will get assigned a value of 0, so that becomes the driver joystick. And we like to have a driver and an operator so that way we can offload some of the work for the operator, and we can control which joystick controls what. So the next thing is our PWM. So remember our motor controllers that we were looking at. This is where we're going to determine which one is plugged in where. So the one that is called front left drive is assigned value of 0. And again, later on when we switch to CAN bus, we will change things so that we can refer to the appropriate CAN bus channel so that we can change it in one spot and not have to worry about it, et cetera, et cetera. So obviously, if I have the right or the left motor, I am going to need a right motor. And a couple things, you'll notice I'm capitalizing this. I'm capitalizing everything that is a constant variable. I guess I can't have constant instead of a variable, so that by capitalization, it's an indication for myself that that is a constant and it's not something I can modify. So the other thing is that I am going to create, there's a couple standard variables that we incorporate. So with our drive base, one of the things that we've found is that our joysticks can be very sensitive, and there's nothing worse than all of a sudden the robot doing something because it's just off a little bit. So what we have is something called controlled deadband. And so this is just a value so that the value, if our joystick's not perfectly centered, it's not going to be driving the robot. We're going to make sure that 10% or less, it's got some leeway there. Now, this is a decimal number, so we use the double data type. And as I go through this, I'm going to assume that you have some programming skills, because that's really all of these concepts. You need to take some intro to programming, and at Huntsville High School, I highly recommend that you take Introduction to Computer Science, because then you'll understand all of these terms that I'm using. But if you haven't taken that, there's some free online courses, Learn to Program Java, et cetera, et cetera. Now, in our slideshow that you have access to, there is a link to our GitHub. And this is our robot from 2020, Infinite Recharge. And you can see all of the different constants that we use in that. So it's a very handy resource for you to take advantage of. So we're going to add a new folder right now. And over here, Java FRC robot, we're going to right click that. We're going to add new folder. And we're going to call this folder UTIL. So this is our utility folder. And in our utility folder, we're going to right click that, and we are going to create a new class or /command. So that was right click there. And I'm going to select an empty class, and I'm going to call this utils. So Java is an object-oriented programming language. Sorry, I'm just not sure why that's not. Let me try that again. Empty class, utils. Okay, this is, I'm not actually selecting that, so that's why. Now I've got it. Okay, so object-oriented programming, I've already mentioned things are in a class, and the key thing is that in our program we can create an instance of the class and access the different variables and functions. So what we're going to do is we're going to create a limit function to begin with. Now this time I've added slash and 2 asterisks. So this gives me a multi-line quote. In this case, it's only going to be one line, but this, I use this before functions because that can pop up in IntelliSense, which is really handy. So this is my own function, public static. So public, we can access it. Static, I don't need to create an instance of the utility class. I can just access it. And it returns a double. It returns a decimal number. And so I'm going to call it limit, and it's going to take a value. So opening squiggly brace, closing squiggly brace, and I'm using the arrow keys to go back. Now, don't worry about the red. You'll see the red indicates there's an error and it must have a return type. Well, I got to write this so that I have a return type. So what I'm going to do is I'm going to write an if statement. So an if statement, if value less than equals negative 1.0. So our motor controllers take a value from -1 to 1. So if I accidentally type send a value of -1.5, that value is not going to be, it's out of the range and we're going to have an issue. So I'm going to limit this by forcing it. If it's lower than that, I'm going to return -1.0. Now, for those of you in the programming class, normally we put a squiggly brace after there. Because then we can have a block of code. In this case, I've only got one line. I'm just checking, so that's why I'm just simply doing this. So else if my value is greater than or equal to 1.0, and in that case, again, I go after the bracket, enter, I'm going to return 1. So if it's too small, return -1. If it's too big, return 1. And then our final situation, else. In this case, I'm going to return a value. And the value is whatever I passed. So you'll notice that red line disappeared because now when this method runs, no matter what, something will get returned. So that satisfies the compiler, which is great. So that little utility will be very handy later on. While I'm in this folder, I'm also going to create my deadband. Now, this is where things can get a little tricky. You'll notice there's some lines in VS Code that kind of help you line things up. You'll notice that I'm using tabs to space things out. So it's like, here's my if statement. So that's part of that. And then that ends it. So it makes it a little easy. So this squiggly brace is underneath public. So I know that's the end of that. So I want to go after that. And this is where I'm going to add my next method. So in this one, I'm going to type what it does. So what I'm doing is I'm using the math class and I'm using the absolute method so that it's returning a positive number no matter what the person types in. So I'm going to check the value. I just realized, oops, I'm going to cut that out because I screwed up. Okay, I forgot to make the name of the class. That was silly of me. Public static double. So I'm returning a double value, and this is called apply deadband. And again, you'll notice how I capitalize. So if I've got a method that's part of a class, I start with a small letter. If I've got a class, I start with a capital letter. If I have a constant, everything is capitalized. So these are just some of the kind of traditions that we follow. It's a value, it takes a deadband amount, and in here, there's my if statement that I was working on. So opening bracket, closing bracket, you want to be very careful. If you're missing a bracket, you're going to get an error. So you always want to double check that your brackets match up. And in here, I'm going to return 0. So basically, remember I set my deadband value to 0.1. In this case, if it's less than that, so let's say it's 0.9, it's going to return a value of 0. And else, I'm going to return value. So again, no matter what, it's going to return. So this allows me to fix the sensitivity of my joystick. And your driver might go, you know what, like I feel like there's this delay from when I'm pressing. So in that case, I'll try to reduce the deadband, maybe set it to 0.7. So you can play with those things. Now that we've got this, we're going to create a subsystem. So by right-clicking the subsystems folder on the left here, creating a new class, we can now select it, and we're going to search for subsystem new. So there it is. And now it's going to ask us to name it, and this is the name of the class, so we're going to use drive base with the capital letter. So our subsystems, on our robot, we want to have subsystems for everything that we're going to be accessing in code. So let's say you have an intake, you'll have a subsystem for the intake. You have a shooter, you'll have a subsystem for the shooter. So these kind of define the different parts of our robot. So we have added this. And in here, we're just going to add a comment here because we want to document what everything does. So we're just a quick explanation what it is, what motors we're doing. So for our practice robot, we're using 2 sim motors. And we're using arcade drive. So arcade drive, the joystick Y controls throttle. And the joystick X controls rotation, so you can turn it. This is slightly different than the slideshow, but you get the idea. So in here, we need to add our motor controllers. So we're going to public class drive base, and so this is our class, and you'll see it extends the subsystem. That's great. So in our class, we are going to add private menus. So private is new, and basically what this means is that I can't manipulate this from a different class. It's private to this class, and that's a handy thing. Now, remember we're using the Talon motor controllers, and that's part of that, so you can see it automatically imports that library, which is great. And what we're going to do is our left leader is going to be the motor at the front on the left-hand side. And for this system, we're only using 2 motors, but if we had 3 motors, then we would have a follower motor, and the leader sets the speed and everything, and then the follower uses that speed to match it. So new Talon, and here what channel? Well, this is part of our constants. Front, left, drive. And see, this is where it's really handy because we can access that constant and we can look at our code and go, oh, that's got to be plugged into number 0. So we can check our wiring, make sure everything's in the right spot. So that's our left-hand side. We need to do the same thing for the right-hand side. Right leader. And this one is front right drive. Now, a couple things that I want to mention. Number one, I want you to when you're learning, look at the different errors. So anytime you see a squiggly underscore, that's an error. In this case, it tells me I'm missing, it's a syntax error, I'm missing my semicolon. In Java, the semicolon is kind of like a period in English. It ends the sentence. The other thing is that you can build the robot code, and when you do that, we should get an error in here, build failed, and it's going to explain why, and it's even going to tell you what file it is, what line it is, and what the error is. So it's really good practice to do that kind of thing. So now you can see when I build it, it's going to go through, and I should have a success. So as you're building code, it's really good to practice that and make a change, see what the error is so that you understand what you're going to recognize. So in here, it even tells me error, there's a missing bracket. So it's really helpful, and you are going to make typos. So it's really good practice to do a line of code, build it, a line of code, build it, and stuff. I've kind of skipped that because I'm trying to get through a lot of stuff in here. But as you're practicing, that's really good. So there we go. I have my motor controllers set up. I'm also going to be setting up my differential drive. So differential drive is a class that we use. And if you're looking at the differential drive, it explains what it is. So this is really good to read through these things so you understand what they are. Equals new differential drive. So I need two variables with this. My first one is my left leader, and my second one, so it's basically what's your left and right, and there you go. So I'm missing an equal sign. So now you can see this is yellow, so it's not an error, but it's just saying, hey, you've created this, but you're not using it anywhere. So we're going to be using that in a moment. So we've got everything. Here's our drive base. I'm going to just skip down to the bottom and go up a line because I'm going to create my own method. So this drives the robot. So arcade controls, that's different from like a Jeep or tank controls, where with tank you have two joysticks, one to control the throttle and one to turn and everything. So public. So this is my own method. So void means I'm not returning anything here. It's public. I can access it from other classes, and this is called arcade drive. It's going to take a throttle value, and it's going to take a rotation value. So to go straight, you apply the rotation of 0. There's my squiggly brackets at the end, and now I click, and what I'm going to do is I'm going to take my rotation, and I'm going to take it and multiply it by -1. And because there we go. So because drive is a differential drive, all I'm doing is I'm calling the arcade drive from this. So this is just because if we're flipping our motors and stuff. To be honest, in our practice drive, I can have it 0, but just which side we set as the front, I need to flip it. So that's our drive base, and that's our drive base subsystem. So now we're going to add a command. So we're going to right click, create a new class command, and we're going to look for command new. There it is. And in here, we're going to call this drive with joystick. Now, the idea here is we're going to have a drive with joystick so the driver can do it, but we can also have other drive commands for autonomous where it's like drive based on time and stuff like that. So up here, we've talked about some of the imports. We're going to add a couple of imports right now just so you see how that's done. So when you do import, FRC is our our things. So FRC.robot. And you can see the classes that are in my folder here. So over on the left, constants, main, robot, there they are. So I'm going to import that constants folder so I can access it. And I'm going to also import my FRC robot dot my subsystem. And you'll notice that the asterisk, so that pops up, import everything in here. I don't like doing that because I want to control what I'm importing. So those are the libraries that I'm importing that I'm going to take advantage of. So I'm going to, down here, add a comment. Now, I'm making it very short. If you can please check the slideshow, you'll see there's quite a bit of text in there, and I highly encourage you to put all of that text in there because it just makes life so much easier. So here's my class. So at the beginning of the class, this is where I want to create all of my variables. And in here, I've got a few variables. So these are all private because I don't want to be able to access this from other things. So this is part of encapsulation of object-oriented programming. And that's covered in the grade 12 course. So some of these things I'm just going to say, don't worry about it. Take the programming course so you understand it. But for this, let's just get it done. So private final. And the double supplier is a function. There's some reasons I'm not going to go over in this tutorial why we're using that. So we've got our drive base, we've got our throttle, we've got our rotation. Those are all the values that we need for this. And I am going to add, there's our function. So we're going to make a slight change here. What we're going to do is we're not going to call this function by itself. We're going to call it and we're going to pass some values. So drive base being one of them, a double supplier, which is what we've got. And this gets a little confusing. So I'm going to take a moment to explain this. So these are the parameters that I'm now, when I call the drive with joystick, I have to use these parameters. And in these parameters, I'm going to refer to this dot drive base. So this dot drive base means, okay, in this class, these are the variables that belong to this class. So this is the class, and that's the drive base. And we're going to take that, and we are going to assign it the value of drive base, which is this value. So they're two separate values, even though we're using the same name. So it's a little confusing. And we just need to set all the values here. So we're establishing them, and then we're going to use this add requirements. And the add requirements is drive base. We're going to require that we use the drive base subsystem for this particular class. So that's great. So in here, there's some default functions here. One of them is execute. So whenever the drive base, the drive with joystick subsystem command, whenever this command is scheduled to run, it's going to run the code that's in this spot. And so what we're going to do is we're going to take our drive base, and remember we created that method called arcade band, and we're going to run that method. Now, I'm going to add my variables in here. So you'll notice that I'm going to use my utilities and I'm going to apply the deadband. I'm going to take my throttle value and I'm going to get as double, and I'm going to pass it my constants and my control deadband that I created earlier. So that will set my throttle. And then you'll notice here's the rotation. I'm going to put this on a new line. And the reason I'm putting it on a new line is just to make it easier to read. So this time I'm taking my rotation value, getting it as a double value, and again, I'm taking my constants and control deadband. Now, you'll notice there's a lot of brackets here, so it's really important. So this squiggly brace closes my execute method. That bracket, this bracket with the semicolon, closes the call to this method. That bracket closes the call to this utilities one. That one closes that. So it's really tricky to do. That's why I put things on new lines so that I can kind of line things up and make sure I got everything organized. So there we go. Now, the other thing is there's this function called end. So this is called once the command ends or is interrupted. And basically, this is just a safety feature. But what I want to do is I want to make sure that my arcade drive, if the robot is interrupted, I want to make sure that the motors get shut off. So I'm setting the values to 0. So a lot of setup, and you might be going, geez, that's a lot. It is. But by structuring it this way, it gives us a lot of ability to change things and modify things really efficiently and effectively. So it's a lot of initial work, but it pays off in the end. So robot controller is our next file. And this is where, or robot container, this is where all the good stuff happens. So here's my package for this. And in my package, I'm going to import my static FRC .robot dot constants. I'm going to import all of the constants. I just said I don't like doing this because I want to control. In this case, I want to make sure I have access to all of the constants at my fingertips without having to remember to add them manually later on. So for that case, I'm going to add that. So here's the robot container class, and down here, that's where it's created. So right after it's created, I am going to create my own controller here. And they've given some sample code just below where I'm typing. Private final. So this is an Xbox controller that I'm using, and it's going to be called the driver. So new Xbox controller, and I'm accessing my driver constant. So there we go. I've now set up so that the joystick that's plugged in first is the one that's the driver's going to be using. And I'm going to add a robot subsystem. And in my robot subsystem, I'm going to add my drive base. So private final drive base. And it's tradition to use the same word, but a small letter to indicate you're creating an instance of that class. And so I've created a new instance of the drive base class. And sorry, I'm just double checking my notes here. I'm going to scroll down. So this is the default program code that's there. I encourage you to leave it in so that you can reference it. But once you understand it, we can delete it. Robot container, here it is. So what I'm going to do is I am going to set my drive base control. So I'm going to set my default command. So this is where it's a little tricky. Now, what I'm going to do is I'm going to create a new drive with joystick class or instance. So that's the class that I've created. Why am I getting an error? So there we go. So what I've done there is it couldn't figure out what we were doing, so I'm telling it what we're doing. So drive base. So I'm saying, okay, we're going to use this drive base that we've created, and then I'm going to add a comma and 2 brackets. So I'm going to put this on a new line. The 2 brackets and then the arrow. So I'm not going to get into what this is at this point, but basically what I'm going to do is I'm going to take my driver and I'm going to get my Y value, and in here my controls, and this is my drive controls. So this is why I set up my controls, so I can kind of access all the different elements of my joystick by just typing the word controls. So there's that. And so basically what I'm doing is I'm passing a value based on calling this function, the Xbox controller that has a get a Y and X value, and you pick which joystick you're getting. So I'm calling this function and I'm returning the value which I'm going to use to pass it on. So in here, I am accessing, oops, I've got driver, I forgot my .getX. So I'm accessing my X and Y value for my joystick to be able to do this. And I'm missing a bracket. Oh, sorry, I'm just double checking. That bracket closes that. That one closes that. That one closes that. You can see where the brackets are. So just making sure, this is where there's a lot of potential for mistakes. So let's just build this. If I get an error, then I've made a typo somewhere. And as I said before, as you're going, you want to make sure that you figure this out. Robot container line 65. Oh, remember how I deleted those lines? Well, that's where I'm running into my problem. So that's my only error, so that's okay. So that was an issue. So this returns a command. Okay, I stupidly got rid of that code, and I should not have told you to do that. So I'm just going to go back and type that in. And I can't find what the code was again. So this returns a command. So return I'm just going to return this for now and pass it those values. Well, that was stupid of me. Okay, so that allows me to. Okay, so I can build my robot. That's great. We have created our program. Everything is done. Now, I'm just going to check one thing before I wrap this up. The next stage is you want to connect to your robot. So you would need to power your robot on, connect to the Wi-Fi for the robot. Once you've done that, you can click the three dots and deploy. I can do that, but because I'm not connected to a robot, we're going to have an issue there. But once, and the issue is I'm not connected, so that's fine. But I can test my robot code. And once you've deployed your robot code, you should be able to open up your driver station. And there's our driver station. And really important, when you are testing any new code, always have your robot raised up so that the wheels are not touching the ground, so that there's no issues. And there's our smart dashboard. So you can see I'm obviously not connected, but I would click, these should go in green after I've set up the program, and I should be able to click enable and then test my program. So any big change, any new change in your code, always test it. Never put a robot on the ground or on the playing field without testing your code in advance so that you know what's going to happen. You'll also notice you want to make sure that you're in your right mode here so that you're in your teleoperated mode before you enable. So hope that is helpful. Looking forward to getting more of our robot started. At this point, we should be able to drive the robot, and that's a great start.